Today we're going to be learning about multiples and factors. Before we get working with specifically those two things, I'm going to have you guys take a second, pause your video, and I want you guys to try this. Oops. I want you guys to try the Ignite question number 1 at the top of the page. Okay, hopefully if you check your answer, you should have got 31 as your final answer. You get that because when you take your values, really evaluating, remember, this just is a fancy word for plug in. So whatever A is, -2 should go in for A, B is 7, so 7 should go in for B, and C is equal to 10, so 10 should be plugged in for C. And then we just follow our order of operations. Now, today we're still going to be working not necessarily with order of operations, but we're going to be talking about multiples and factors. So we're still working with integers, but we're looking at kind of a different side of them. So the first thing that we're going to look at, obviously we're going to start off with just a couple vocab words, and that is, what does it mean to be, let's start with, what does it mean to be a multiple? So specifically, it just means that it's a number that can be divided by another number. So for example, we could say that 20 is a multiple of 5 because 20 can be divided by 5. Now, when we get to working with things called LCMs, this just means the least common multiple. And we always look at this whenever we're comparing usually 2 or 3 different numbers. So what exactly does it mean to be a least common multiple? It just means that it's the lowest common number of 2 or more quantities that those 2 numbers go into. So for example, if we're talking about the least common multiple of 2 and 6, or 2 and 5, well, we'd have to pick a number that both of those numbers can divide into. So the least common multiple between 2 and 5 would be 10, because they can't both go into any of the numbers between 2 or 5. They can't go into 6, 7, 8, 9. 10 is the next number that both 2 and 5 can be divided into. Now, let's start off with let's go over our first couple examples. We're going to come back to defining factor and greatest common factor in just a moment. So first and foremost, let's actually start by finding multiples of a given integer. And specifically, I want you to find 5 multiples of an example 1, the number 2. So all it means to be a multiple, remember, is it's just a number that can be divided by another number. So if I want to find multiples of 2, one of the easiest ways to find that is to take 2 and multiply it by any number that you want. There's a lot of answers to these problems. Specifically, there's actually, well, not specifically, but there's infinitely many answers to the question, give me a multiple of 2. So for example, you could go pretty basic. You could go, well, 2 times 1 is 2. Technically, 2 is a multiple of 2 because 2 can be divided by 2. But you could take 2 times 3 and get 6. 6 is going to be a multiple. 2 times 4 is going to be 8. 8 is a multiple. You could even go more complicated. You could go 2 times 100, and that just means that 200 is a multiple of 2. But really anything, 2 times 8 is 16. As long as you take 2 and multiply it by 5 different numbers, the results of that are going to give you anything that is a multiple of 2. So 5, for example, again, you could go crazy. You can go in order. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. You could just go and write them out in a list. We're never going to deal with decimals for various reasons, mainly because we're working with integers, and integers can't be decimals. But you have your 5 integers of 5. So take a second right now. I want you to pause your video, and I want you to try example 3 on your own. Hopefully when you tried examples 3, I know I only said 3, but 3 and 4, you should have you could have had these, but you could have had any numbers that, as long as you took both 10 and 12, as long as you multiplied those by some number in the universe, then your number that you have is a multiple, okay? So now we're gonna get into what does it mean to be a least common multiple? Or we'll call this, an LCM for short. And honestly, the answer is kind of in the name. You're gonna find the least common number that both of the two that I'm gonna give you, 2 or 3 that I'm gonna give you, go into. Now with larger numbers, sometimes this can be more complicated. So I'm gonna show you kind of a process that works for any numbers that I'm going to give you. And it involves kind of finding different numbers that multiply to give you the 2 numbers that we have. Specifically, we're gonna break it down into its prime factorization. And all that means is we're gonna break, for example, we're gonna break 42 down into all of the smallest numbers that we can that aren't decimals that can multiply together to give me 42. So we start by I usually just make kind of a tree. I just break it down. I say, okay, well, what are just any 2 numbers that multiply to give me 42? There's a lot of them out there. I'm not gonna show all the ways, but when I looked at this, I knew that 6 times 7 gives me 42. Now, ideally, when we say prime factorization, we just mean really any number except 1 in itself. I could have done 42 broken down into 1 times 42, but that doesn't really help me at the end of the day because it hasn't really changed the number. The goal of this is we want to change the numbers to be as small as possible. So 7, for example, that's about as small as that goes. The only numbers that multiply to give me 7 are 1 and 7. 6, on the other hand, there are 2 other numbers that multiply to give me 6 that aren't 1 and 6. And hopefully you're getting that down. It's just 2 times 3. Now, all of these numbers, 2 can't be broken down anymore. 3 can't be broken down anymore. 7, all of those numbers, the only thing that multiplies to give you each of those is just 1 in itself. Now we're going to do the same thing, but we're going to do it with the number 16. And again, 16, there's a lot of different numbers that multiply to give me 16. Pick 2 of them. Like, I think I looked at this and I said, well, I know 4 times 4 gives me 16. I don't want to choose 1 and 16 out of all of those numbers, though. Same thing with this, 4, I don't want to choose 1 and 4, but there are 2 other factors of 4. The 2 other numbers that multiply to give me 4 are 2 times 2. And I have 2 4s, so I'm going to break down both of those 4s into their 2 times 2 factors. Now 2, the only number that goes into 2 from here on out is really just 1 and 2, so we know that we're done. Now, part of finding the multiple, you're probably saying, Ms. Hardy, this doesn't give me 1 number. If anything, we have more numbers. The goal is to find, again, the smallest number that both 42 and 16 goes into. So to do that, we're going to go through each of those numbers at the very end of the problem, and we're going to pull out all of the unique ones. So for example, I'm going to look through each of my lists, and I'm going to start by looking at this 3. Because 3 doesn't show up anywhere in any of the other spots at the end of that branch. So what that tells me is that my least common multiple at least has to be 3. Now we're going to do that with really all of them. So I'm going to say, well, I look for the unique ones. So 7 doesn't show up anywhere else in the problem. So 7 is also going to come down. As of right now, my least common multiple is going to be 21, 3 times 7. Now, obviously, 42 doesn't multiply by something to give me 21. We have to tackle the last thing that's in here, and that is the 2. Now, I realize in 42, this one has 1 2 left over. In 16, that one has 4 2s. We don't total them up. We just choose the number that has the most amount. So 42, yes, it has 1 2, but 16 has 4 2s. So what we're going to do is that's the one that wins. 16 has more 2s in its prime factorization than 42. So I'm going to bring all 4 of those down. And all together, when we multiply those together, that's going to give me my least common multiple. So to do that, I'm going to multiply them all together. When you do so, you get, swoopsies, you get 336. And if you'll notice, if I wanted to check my answer, if I take 336 and I divide it by 42, you're going to notice that that actually turns out to be a pretty nice number. It turns out to be 8. And if I take 336 divided by 16, I get 21. And that lets you know that that's going to be your least common multiple. So what I want you to do right now, I want you to pause and I want you to try number 6 on your own. Okay, hopefully you got your least common multiple to be 650. Now I'm going to briefly walk you through how you got that. Hopefully you broke down the numbers as you can see on the video. 25, the smallest it can go down to is 5 and 5. 50, like I said, you didn't have to do 5 and 10. You could have done 25 and 2 and broken that down. But either way, at the ends of your branches, you should have had a 5, a 2, and a 5 for that one. And then 65, the only 2 numbers other than 1 and 65 that go into it are 5 and 13. So remember, we start by pulling out the unique ones. 2 and 13 show up in only one of the lists. So those both come out. And then we look at the 5s. And we look at which list has the most number of 5s. So 65 only has 1 5, so we don't use that one. The other 2 lists actually both had 2, so 2 5s are going to come out total. And then we multiply them all together, and you have your least common multiple. Okay. Now we're going to go through and we're going to get into factors. And the reason that we're going to do this today is simply the fact that factors kind of work the other way. Multiples, it's mostly about multiplying certain numbers together, whereas factors, we use division to break things up to find things that are factors of a given number. Now, what exactly is a factor? A factor is simply just a number that can multiply with another number to produce a larger number. So there's a lot of numbering things going on here. But if you look down at the bottom of the page where it says find factors of integers, first and foremost, Ms. Hardy had a typo. It says find all the multiples. Obviously what we're doing is going to find all the factors. Okay. And to find all the factors of whatever number it is that I'm going to have you work with, how we do that is we start by just using division. To find factors of 40, we want to find 2 numbers that multiplied together to give me 40. And we were kind of doing that in the 2 examples above this when we were breaking it down. So 40, I'm going to do the same thing. I'm going to say, okay, well, what are some numbers that multiply to give me 40? Well, 1 times itself is always going to be what we call a factor pair. 1 and 40 are both factors of 40 because if you multiply them together, we get 40. But there's a lot of other numbers that do that same thing. So for example, now, if you're not sure what numbers multiply to give me 40, this is where division comes in really helpful. So for example, if I want to check to see if 2 is a factor, I'm going to take 40, I'm going to divide it by 2, and we're going to see what kind of number we get. So if I take 40 and I divide it by 2, you're going to notice that we get a nice number. We get 20. When I say nice, I simply just mean no decimals. Sometimes your factors could be pretty large. Sometimes obviously they will never be larger than the number that I give you. But division helps you find those factors. So you'll notice if I try taking 40 divided by 3, you get a decimal for that. And that just means that 3 is not going to be a factor of 40. So if we keep going, 40 divided by 4 ends up being 10. 40 divided by 5 ends up being 8. If I do 40 divided by 6, I get a decimal. That means it's not a factor. 40 divided by 7, also not a factor. So that's not going to be in my list. And you'll notice then as soon as I reach the next number, it would be 8. And 8 is already part of my list. Once you reach that number, that just tells you that you know you're done. You found all the factors, which is kind of cool. So all of the factors of 40 are going to be 1. And if you really want to, if you're like Ms. Hardy, I like putting these in order. 1, 2, 4, 5, 8, 10, 20, and 40. all of these are all of the factors of 40, okay? So now you get a chance to do it on your own. Pause the video and try example 8 on your own. You should have gotten all the factors of 10 should be 1, 2, 5, and 10. You'll notice that if you try dividing by really any other number out there, it always produces a decimal, and those are not considered factors. Now, factors, usually most of the time, I'm not going to ask you to just find a factor. Usually we're going to find what's more useful to us is to find the greatest common factor. All right, so greatest common factor, what exactly is it? It's just the largest factor that goes into the given numbers that I'm having you work with. And greatest common factor, most of the times it'll just be between 2 and 3 numbers. But at some point, you're gonna be working with maybe up to 4 numbers. And you're gonna find the largest factor that goes into any of the numbers that I give you. So keep in mind, a lot of times we'll use GCF just to shorten it. So if you turn to the next page, you're gonna notice that I'm saying find the greatest common factor, okay? So to find the greatest common factor, one thing that's kind of implied is that you actually have to know what some of those factors are. So the first thing that we're actually gonna usually do is I go through and I make a factor list. I factor each of those numbers individually. So factors of 10, obviously 1 times 10, those are all 1 and 10, 1 in itself, those are always factors. But 10 we just did. I already know that 2 times 5 and 1 times 10, but those are the only factors of 10. Now 35 on the other hand, if I'm gonna go through and find all the factors of 35, we always start with 1 in itself. 1 times 35 is gonna be one of the factor pairs. And this one actually only has one other. If I divide 35 by 2, I get a decimal, not a factor. 35 divided by 3, decimal, not a factor. 35 divided by 4 is also a decimal, therefore not a factor. You don't reach your next factor until 5. If you divide by 5, you get 7. And then the last number we would really have to check is 6. That would come after 5, but that doesn't work. That produces a decimal as well. So if we're going to find the greatest common factor, the next thing that I'm going to go through and do is I'm actually going to start to just figure out, okay, well, what are at least some common factors? Well, if I'm looking through my list, they both have a 1. They both don't have a 2. They both have a 5. And they both have a 10. So the only numbers that they actually have in common are 1 and 5. And the greatest common factor, the number that's the largest out of all the common factors for us, is 5. And you have your greatest common factor. 5 divides 10 and 35, and it's the largest number that divides those two numbers, okay? So let's try another. Example 10, first and foremost, I'm gonna start by making my factor list. Now 24 and 16, both of these have some larger factors, or a larger number of factors, I should say. But if we divide by 1, we obviously get 24. If I divide by 2, we get 12. If I divide by 3, we get 8. Divide by 4, we get 6. And if I try divide, that's the last number I have to check, 5. If I divide by 5, I get a decimal, so it's not a factor. And we're done with 24. 16, on the other hand, again, start dividing. 16 divided by 1, which is 16. 16 divided by 2, which is 8. 16 divided by 3, decimal, so not a factor. 16 divided by 4 is 4. And actually now your list is done because there are no other non-decimal answers between 4 and 4. And now I'm going to go through and I'm going to find all of the numbers that they have in common. And it might be a lot. For example, they both have a 1. They both have a 2. They both have a 4. They both don't have a 3, don't have a 6. They both have an 8. They both don't have a 12, and they don't have a 24. So what that means for us is that I have 4 factors actually in common. I have 1, 2, 4, and 8. And for the greatest common factor, it tells you we want to choose the largest, which is 8. Okay, so now pause your video. I want you to try example 11. Yes, there's 3 numbers, but I want you to try and see if you can figure out what the greatest common factor is between all of those. And go. All right, you should have gotten your GCF, your greatest common factor, to be 3. Now be careful with this one. Hopefully you got the following numbers that I did. When you have 3 numbers, it has to be a number that's listed in all 3 lists. So one number that I know sometimes confuses some is the fact that 9 shows up in 2 of the lists. It's not enough to just show up in 2. It has to show up in all 3 of the lists. So since there's no 9 in this 3rd list, that just means for us that 9 is not going to be a factor. The only numbers that show up in all 3 lists are the numbers 1 and 3, and we have to choose the largest. Okay. Now, if you look at the next part, the add and subtract fractions, you don't have to actually do this. We're going to do this in class tomorrow. Remember, make sure bring your calculator. I'm going to show you how to do this in class. But if you would like to, though, down below, there are a couple examples that you can try if you want to start now. Hold off on number 3, but if you want to try 2, 1, 2, and 4, we're going to go over these in class tomorrow. All right. Thanks, guys. It's awesome meeting with you. As always, if you have questions, email Miss Hardy. Have a fabulous day.